I'll be right back, Stephen. I got to find the video backup for today. Okay, Jared, you can put your hand down for now. We're going to get started in about 1 minute. I just want to make sure no one else is coming to class because the last few times there's been people show up about 1 minute after, and I don't want them to miss because then they sort of feel like they should watch the video when they don't really have to. So we'll wait until my clock says 4:01 in the classroom, so you've got about 90 seconds if you want to grab water or, play a video game for 90 seconds. I'll be right back. Okay, we're staying 4:01. So I've given you both the tools. We're going to just work a little bit more on graphing to find an equation because some people were still having trouble not just understanding this, but just needing some more practice with this. And I know a lot of people left today feeling like they needed some class time next time to work on it. So we're just going to slow it down a little bit, and we're going to look at this some more. All right? And maybe when we're done this week, we are going to develop our own graphic picture. You can see there's a SpongeBob there. So you're going to develop your own dot to dot, and you're going to be using some points on a graph to do that. So think about what you might like to produce in your dot to dot, and then people will connect the dots, draw the points, connect the dots, and maybe get your picture. So you can be thinking on that one. We're going to spend a bit more time on graphing, and we really want to go over this point that you can use a linear graph to find any point that solves an equation once you've got a couple of points. Oh, sure. Somebody's here checking on stuff. Oh, the phone. Oh. So we've got 3 points here. X is 1, y is 3, x is 2, y is 4, x is 3, y is 5. So Jared, why don't you, using the pen, put on the very first point. Now I'm going to draw, I'll spend my time while you guys are putting the points on the graph, just trying to get the numbers below. I almost fooled us by making it look like I could do this for a second. So Jared, I don't know, do you have the pen? Can you see the pen there? Oh, there we go. Okay, so Stephen, you put on x is 2, y is 4. Okay. And I'm going to put on, if x is 3, y is 5. So we've got our graph kind of working out here. Now you can see I've got a line tool on here, so I'm going to use that. And I'm going to start my line right at x is 3. And I'm going to draw the straightest line I can that goes through all of those points. And it might be a little bit off, but for the most part, I think it's going to be on. So there we go with our x equals and our y. So now we're saying, what is x when y is 7? Well, we can see that y is, oh, I drew 2 lines. I'll get rid of one, just hang on. I'm not sure how I drew 2 lines there, but that's okay. Get rid of one. There we go. So there's the lines. Oh, look at that already. Some genius child has come across, and they've shown that when y is 7, this is the point where the line intercepts. So now what we have to do is draw a straight line down. I wonder if one will just show up to where the x point is that meets with that line. Well, I'm seeing dots show up. It's very interesting today because there's a ghost in my machine. All right, Stephen, good job. All right, so let's see if that's right. If x is 4, or sorry, if x is 4, y is 7. So on the point on the graph where we said, what is x when y is 7? We can see that x is 4. So now we have to figure out what is the equation. So we know that we went up 2 more. Any thoughts on what the equation might be that we're solving here? Because that's another good part of this. I'm going to just write x is 4. What's that? Any thoughts on that, guys? See if you're, Stephen says, y equals x plus 2. So let's write that down. I'm going to put it in the text box. The equation is x equals, no, y equals x plus 2. That's what it should be, y equals x plus 2. So I've got to make this bigger again. So it should be y equals x plus 2. Now, look at another point there. Let's look at 8. Does it fit the equation? So let's go across at 8. One of you two can do that. I think Stephen did the last one. Oh, Jared was drawing on the graph. Thank you, Jared. All right, so let's figure out what it is for 8. That's the next line up. I didn't write it on, but we can see that because we're going up by 1. So let's figure out what the answer is for 8. Okay. When x is 5, y is 8. Is that the case? It should come across to 6, so I think maybe I wasn't very even with my things. Guys, 6 plus 2 is 8. So, oh, but then how do we get that 7? Here, 3, 4 plus 2 would be 6. I think y equals x plus 2. That should have been 6 there. All right. So I think we messed up with our thing here. Oh, I see we went a little past the line, so it should be at 6. So this is one of the problems when we're graphing and we don't get quite on the line. So when x was 4, y should have been 6. So x was 7, y should have been 5. Okay, and oh, it was. X is 7, y is 5, so it just didn't come over quite far enough. All right, so if the equation is y equals x plus 2, that should have been when y is 7, x is 5. So I'm going to just put that there. Let's see if we can make our graph fit that now. All right, so let's clear. Let's see. So, see if we can do that wrong. Yeah, I thought it was wrong too. All right, so let's just do that. And you know what I can see is that my graph right here has too much space. Remember we were talking today about the importance of the graph being absolutely even? I should probably add a line there below. See if we can do a straight line. And then it'll probably be better. Now I think we'll probably get an even graph. So that's what happened. It wasn't you guys, it was that my graph wasn't very evenly spaced. And I should have had probably another one there too. So we're going to say that what is x when y is 7? We're going to plot those points again. So we're going to do 1, 3. And I'll just do those quickly. X is 1, y is 3. And then my points won't show up. There we go. X is 2, y is 4. X is 3, y is 5. So now x is 4, y would be 6. X is 5, y would be 7. So that's a better drawing graph. There we go. So we draw a straight line through, and we see that this time, yep, that was the problem with me in my original graphing. These are hard for me to draw too. So there we go. There's our straight line. So when y is 7, 1, 2, 3, 4, 5, 6, 7, we can see that y is 1, 2, 3, 4, 5. That's better. X is, no, sorry, when y is 7, x is 5. Okay, so 7. Let's draw that on here. Because we know it's x plus 2. This is 5. Now it works fine. Cancel that. Here in my line. All right. So we can see, oh, and somebody's already drawing the lines for me, and I can see that they work better. So let's move on to the next one. I wanted to be able to get them both done, and we're already at 409. Okay, you can use a linear graph to find any point that solves an equation. So let's graph and find an equation for this relation. The equation this time is actually y equals 2x plus 5. So let's figure out our table of values here for the 3 points that we have. And I'm going to just fill in my graph a bit where you guys figure that out and add in the points. So if x is 2, Then what we have is 2 times 2 plus 5, which is going to be what? 2 times 2 is 4 plus 5 is 9. Good. And how about 2 times 1 plus 5? So 2 times 1 is 2 plus 5 is? See if it shows up. Anyone having the magic? Okay. Oh, there it is, 7. A weird little look. And the last one, if x is 0, 2 times 0 is 0 plus 5 is 5. Good. So we're going to have this is our x, and this is our y. And hopefully our graph will be better this time because I was a little more careful in making my spacing right. So I'm going to just draw the numbers. You guys can put some points on there. Oh, we're going to decide that the scale here is by ones. But what about the other scale? Should we be by ones or should we use something else? Oh, those are terrible for. Okay, so we've decided maybe we'll go up by 2. So we'll do 2, 4. Now sometimes this means we have to graph between the lines, which is fine. 6, I'm only going to draw the first 3 because my printing is terrible. So if x is 2, we already see that someone's done 2, 4, 6, 8, so the 9 should be about there. That's right, and this top one we can get rid of. If you use the very top thing on our little tools and click on it, you can get rid of things. All right, so if x is 2, y is 9. If x is 1, y is 7. Oh, I see somebody's tried to do that, but it should go right about there. Let's just see if we can do that. There we go. And we're going to draw our straight line. If x is 0, y is 5. So there we go. There's the last one. So now we're going to take our straight line, and we're going to draw a line straight up the graph that goes right through all those points. Okay? Well, somebody else is helping me. That's very lovely. I'll get rid of mine. Okay, everybody's drawn a line now. All right, so we've got our straight line. What will the answer be for x is 4? So we can go to 4, 1, 2, 3, 4, and we can draw a line straight up from 4. And we can make it go right across if we want to. And then we take that point and we extend it right over here. So according to this, it's 2, 4, 6, 8, 10, 12, 13. So 2 times 4 is 8, plus 5 is 13. So then in that case, that one actually worked out really well. But we have to be very careful with the spacing of our graph, which is why I want you to use graph paper to draw your graphs, or make sure that you're going up, when you're going up on your scales, that when you're drawing them, you're using a ruler and making all your lines the same distance apart. It's okay if you're doing an approximate graph to just be kind of drawing them on paper, but we need to be precise. We talked about that in math today. So I've got a little homework for you today, and I've still got 2 minutes left. Any questions on this, you guys? Excellent. All right. So I want you to figure out a table of values for y equals x minus 2. So on your table of values, I want you to figure out the values for x is 5 and x is 6. So table of values, and then we put x on one side, and we put y on the other, or we put x minus 2 the other one, which is y, right? So if we put a 5 in for the x, we're going to get an answer, and a 6 in for the x, we're going to get an answer. Then I want you to draw a graph of your ordered pairs on a really, really neat graph, and I want you from the graph to show the values, what's going to happen when x equals 7 and when x equals 3. And what I want you to do, and guys, I'm going to come back to it, is exactly what we did here. All right, is mucking about with drawing the lines from, so you can see that right here, what Stephen and Jared did. It wasn't me doing all of this, it was Stephen and Jared. What they've done is they've actually made the connections and figured out what is that point where the sun is sitting right now. All right, that is the point where x and y intersect. All right, so when x was 4, y was 13. And then we checked it on our equation and we were right. So that's what I want you to do for your homework tonight. Are there any questions? If not, you're free to write down your question and leave. And I'm going to turn off the volume now. Let me know when you're done, Jared. I don't want to turn it off too soon. See you later.